We have another assign the absolute configuration. It's important that you practice as much as you can. And this molecule right here is carbone. Notice that this is the level rotatory enantiomer of carbone, but we have to assign the absolute stereochemistry, and that means R or S. And we're looking at this carbon right here. That's our chiral center. So we're going to assign priorities to the group it has attached to it. All right. I have a carbon on the right, a carbon on the left, and a carbon at the bottom. There's one position that's missing, and that would be the hydrogen, which in this case is pointing to the back. I move on to the next atom, and I have a second carbon here. I have another carbon in here, and this one has yet another carbon. When everything that I am comparing is carbon, it would be more useful for us to actually try the parentheses method to see which carbon is more important. All right, let's start with this carbon here at the bottom. Notice that that carbon is double bonded to a carbon. So you treat that as bonds to two different carbons. And it has a third carbon attached to it, so I would get another carbon in the parentheses. This carbon that's on the left, that carbon is attached to a carbon, just one, the one at the top, and there's two hydrogens coming off of it, so I have to put those two in there. The carbon on the right, it's attached to the carbon above it, and it also has two hydrogens attached to it. So right here I have my three parentheses. Notice that the first atom in the three of them is carbon, so I have to move on to the second one. Hydrogen, hydrogen, carbon. So the double bonded carbon that's at the bottom, this one gets priority number 1. All right, notice that these two are exactly the same, so I'm going to need to consider what else is attached to them. So I'm going to have to do the parentheses of this carbon and this carbon right here. All right, this carbon is double bonded to another carbon. So remember, that's two bonds to two carbons in terms of the parentheses system. And it also has a hydrogen attached to it. The carbon on the left side is double bonded to an oxygen, so it would get oxygen, oxygen. And it has attached to another, it has a bond to another carbon. Now you compare the parentheses. Oxygen, carbon, automatically this side is more important. So this side of the ring gets number 2. This side of the ring gets number 3. So I'm going to put a 2 here, and I'm going to put a 3 over here. And I don't have to worry about hydrogen or number 4 because it's in the back. So 1, 2, 3, 1, 2, 3. This is the R enantiomer of carbone. So the R enantiomer in this particular case is the level rotatory. Remember, these two systems have no relationship between each other. This one right here, let's do it real quick. I have two chiral centers though. I have carbon 2, which is the alcohol, it has the alcohol, and carbon 3 has the amine attached to it. So let's take carbon number 2 first. I have an oxygen, a carbon, and a carbon. The hydrogen is pointing to the back. Oxygen has higher atomic number, it gets number 1. Carbon to the left, carbon to the right, they have the same atomic number. I see what else is attached to them. This carbon has, whether you go to the nitrogen or the carbon at the bottom, it's better if you go to the highest atomic number automatically. So we go to the nitrogen. This carbon has nothing but hydrogens attached to it. So this whole side of the molecule gets number 2. This gets number 3. Hydrogen is in the back, so I'm going 1, 2, 3, 1, 2, 3. I'm going clockwise, and clockwise is R. So I know that carbon 2 is R. Let's see what carbon 3 is giving us. So ignore that pink 2. I have a nitrogen, a carbon, and a carbon attached to it. Nitrogen gets number 1. Carbon, carbon, hey, same atomic number, but this one has more groups attached to it, and over here I only have a CH3. So this side of the molecule gets number 2, the methyl gets number 3, and the hydrogen is number 4, and it's important that we notice that the hydrogen is pointing to the front. Now when the hydrogen is pointing to the front, I'm going to go 1, 2, 3, 1, 2, 3, and notice that my pen is going clockwise. It would be R, but the hydrogen is in the front, so it needs to be the opposite of R. So I like to actually write it out, so it's R, but hydrogen is in front, so it's S. So it only applies when the hydrogen is on the wedge. So 1, 2, 3, 1, 2, 3, I'm going R, but the hydrogen is in the front, so it really is S. So for this molecule right here, carbon number 2, which is the carbon that has the OH, is R. Carbon number 3, which is the carbon that has the nitrogen, the amino group, it's S. And I have actually assigned and completed the name for that molecule.